Hello, young scholars. I am honored to stand before you across time and continents. My name is Joseph Louis Lagrange, born in the year 1736 in the Kingdom of Sardinia, what you would now call Italy. Though my beginnings were modest, my fascination with mathematics knew no bounds. Strangely enough, I was first drawn not by the stars, but by the structure and clarity of algebra and geometry. It was only later that the cosmos itself whispered its mysteries to me. When I encountered the works of Isaac Newton, I was awestruck. His laws of motion gave order to the chaos of the universe. But I wondered, could there be a deeper harmony, a guiding principle beneath the push and pull of forces? That curiosity led me to formulate what is now called Lagrangian Mechanics, a way of viewing motion not by the forces acting, but by the path nature chooses to take, using the principle of least action. Instead of saying, how hard, I asked, what path? Yet I did not walk this road alone. I must bow in gratitude to Leonhard Euler, a great mind of my century. It was his mentorship and letters that first encouraged me to dive deeper into celestial motion. His formulations and mathematical style were both a model and a springboard for my own work. As I explored the heavens, I turned my attention to a question that puzzled many. How do multiple celestial bodies like the Earth, Moon, and Sun interact in space? This is what we call the three-body problem. In that search, I discovered something remarkable. 5 points in space where the gravitational pulls of two large bodies balance out. These are now called the Lagrange Points, and even today, your space telescopes and satellites rest there like celestial dancers in balance. In my time, I had a most formidable peer, Pierre-Simon Laplace. Though we differed in our approaches, he used probability and statistics. I used geometry and analysis. We shared the same goal, to understand the stability of the solar system. It was a fruitful rivalry that drove both our works forward. And then, as centuries passed, new minds emerged. Carl Gustav Jacobi extended my equations with beautiful new transformations. William Rowan Hamilton, with profound insight, created a sister theory, Hamiltonian mechanics, which became the bridge between classical and quantum physics. And then came Henri Poincaré, who reminded us of nature's unpredictability, showing that even in perfect equations, chaos can bloom. Even now, my methods live on. Engineers, astronomers, physicists, they all speak the language of the Lagrangian. When NASA placed the James Webb Space Telescope in orbit, it was at L2, one of the very Lagrange points I identified centuries ago. When your physicists describe the dance of particles or bend spacetime in Einstein's equations, they often begin with my simple formula L equals T minus V, kinetic energy minus potential energy. Big Teacher tells me that many of you dream of understanding the universe, of sending machines beyond the stars, or decoding the nature of matter itself. Let me tell you, the universe responds not just to strength or speed, but to insight, patience, and elegance. Let your curiosity be relentless, your reasoning precise, and your imagination unbounded. Merci, thank you, and may your paths, like nature's, always find their most beautiful course.